Okay, my wonderful friends, this is Roger Spur, Mud Fossil University, and we're going to talk about the new atomic theory I call electron flood theory. Now, let's start at the end, and then I'll show you how we got there. Now, this is what CERN and Fermilab and all of them I've been looking for forever, is this muon. And electrons, everybody sort of understands electrons are the things that flow through wires and they push things and they create heat and electricity and sparks and all that. Well, that's electron showers. And they come from muon neutrinos and electron neutrinos. And a muon doesn't change at all. It's the same coming in as it is going out, and that's when it crashes. This, when it crashes, it's just a white ball coming in, and when it crashes, it gives these showers. Because that white ball is smashing into all other white balls and just get the hell out of the way. So it creates a shower. These are the two particles they can see at CERN, but they have no idea, really, I believe, that they were ever attached together. These are an electron. When you attach the two of them together, it becomes an electron. However, the muon is dark. It never does anything. So it's the other side of the polarity of an electron. Electron is explosive, so this is the banger, this is the sleeper. This is the heat, this is the cold. This is the heavy, this is the light. Well, however you want to think about it. They're opposites, the yin and the yang. Well, however you decide, and I'm going to show them to you. And CERN knows about it, and they know they're there. They just don't understand how they form molecules. And these two particles here are these two particles right here. Here. You see? There's one and there's the other. This is the explosive one that creates electron showers. This is the muon that doesn't do anything. Now, why do we have them, two of them back to back? Because one of them is an electron. When you snap another one to it, like bar magnets, you have a photon. A photon flies through the air, just pushing everybody out of the way. It doesn't incorporate into them because it's already a complete particle. It's a box. It says, just get out of my way. And it slams into them and gets white and concussive. That's this one here, going this way. That makes them wobble and spin, and the black ones just say, okay, no problem, I'll just keep riding with you unless you want to go crazy and explode. And that's what happened. We put it through the Venturi, and it went crazy, and it exploded. And here it is, going through the Venturi. The black ball is completely separated now, totally 100%. 100%, no question whatsoever. The black balls have disassociated themselves from the white spray of electron showers. And then they reassociate almost instantly after the Venturi. And the black balls come right back. So they come right back in at this point. From here to here, these have to slow down enough to where they can reabsorb or be attracted back. I believe that's what it is. They don't want to, these don't want to absorb the black. The black wants to suck back into the white. Now, they say that there's more dark matter in the universe than there is white matter, and I believe that, because this white stuff exploded off of these black ones, and then some other black ones down here jumped back in, so they had to be laying around. I could tell you the white will smash another white one out of its way. So the white is not being attracted back to more white ones over here. The white is being attracted to, or the black is sucking the white ones in. So there's extra black ones here just waiting around. And I understand that too. And I will show you that in the atomic nucleus and the field that surrounds the nucleus. There's going to be all kinds of extra blacks because they fill in the voids. Let's go look at that. But this is how I feel that I can pretty much, support my electron flood theory. And if you have any other opinions, I want to know. And if you see something in nature that says, well, that can't happen because if you say this, that it's impossible. Well, I want to know about it. Those are the kind of things I want to hear about. I don't want to hear, well, I want to hear about everything, but I like adversity. I like somebody to say, well, that can't happen because if this happened, this wouldn't happen. Because I can tell you right now, I am going to tell you that the muon cannot be separated for more than an instant. It cannot be separated and and held in its own containment. It will try to find any electrons, and everything there is has electrons. The only reason we separated it was because of this violent concussion. Once you leave that violent concussion, that's it, they're back together. You cannot stop it. So if CERN or Fermilab or Don Lincoln or Kirsty or whatever her name is, Duffy, says that you can't see a muon, well, come see me, I can show you some. But I can also tell you this, I can show you them, but I can't contain them, and you can't either. So if you say you've got one contained, I'd love to see it. Okay, we're going to finish this up with the new atomic model, which is the Electron Flood Model. Now, this was the Bohr model. You had protons, neutrons, huge things, and then they decided, well, there must be some little other parts in there, quarks and leptons and all these different things. Well, because they smashed them, they could see these parts I just showed you. But because they were smashing billions of particles at a time, they were literally digging through debris. We were showing you the most clean interactions that exist. And they agree with that. CERN agrees with that. They say photon collisions, you can't get any better than that. It's exactly what I showed you. That was their model. Little tiny electrons way out here and a big chunk of positive here. It never worked. And I showed you, I think, my research, or I will show you, that I did 50 years ago. I showed it would not work. It didn't work. And it doesn't work. It still never could work. Now, so what does that mean? I said back then, the core has to be a dipole. And then, which means there's a positive and a negative. But I could never figure out how that worked. Well, when I saw the light research that Rod was doing, and I could see literally the electrons, and I could see the photons. I showed you this, or I will show you. You see the black and the white, and I said, well, what is that? What the hell is going on there? And I could see it separating. I could see all these things. I could see the waves. I could see the spins. I could see everything. He was just absolutely fabulous, the work he was doing. So, of course, I contacted Rod, and we worked it out, and he helped me, and he goes a different direction. I think I might have mentioned this before. He's got a different interest in this. I am the atomic guy. He does a different thing, and that we will get into at some point. But I have to get past this first. Now, I could see these photons, and I could see what they do, and I could see it's always push to shove, and the only ones that push and the only ones that shove are the white ones. I show them as red here because obviously this is a white background. Now, so the white ones push, and the other white ones that they're pushing against shove back. It's push to shove. Whenever you see that, you get this. That's an energetic reaction. That causes heat. It always causes heat. 100% of the time causes heat. 100%. How much heat depends on how much push to how much shove. If you have a ton coming at you at one time, well, you're going to have to push back real hard. You're going to get a lot of energy, which means heat. And I show that. Well, through the Venturi, we get a ton of energy. Now, and I think it's all free. Now, of course, they always talk about particle-wave duality. Well, of course it is. That creates a big magnetic field in front of it, and the field wave shows only the white ones, though. The black ones don't do anything. They don't care. Couldn't care less. They're just what they call carriers, bosons, muons, whatever you want to call them. They just ride with the white ones. I show that they are the attractors. They are the gravitational portions. I say the black balls are muons, dark matter, gravity, bosons, carriers, whatever you want. Then you have the white particle, which shows red here. They're the electrons. They're explosive. They're the energy generators. They're the pushers. They're the shovers. All right? And they push to shove. All whites, all of them push and shove back. You push me, I'm going to shove you back. And that it creates the electron showers that I showed you coming out of the Venturi. Now, what will the particles look like? What do the molecules look like? What do the atoms look like? I showed that the black ones don't mind being right on top of each other. Couldn't care less. The white ones said, get the hell away from me. So here's what's going to happen. They're attached to the black and whites. We know that. We could see them. But we can see them separate too. Now, the black ones would all be pushed to the center, and the white ones would surround the black center. And they wouldn't mind being touching each other, or they couldn't care less. Now, That's in the most basic form. So you can have always surrounding an energetic particle, and that accounts for the Casimir effect. Any two things, I don't care what they are, magnetic, non-magnetic, powder, lead, steel, you get them close enough, they will push each other apart. That's because these electrons will come close to some other electrons and they'll say, no, 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 you get away from me. They don't want to be next to each other. Now, that allows for the excess black balls to fill in the voids. There'll be voids in between these. And they say there's like 5 times as much black energy as there is dark energy, dark matter, whatever, than there is the explosive side. That accounts for it. We could fill these voids with the black matter. The black balls don't mind being on top of each other, and they love being next to the white ones. There it is. As far as I'm concerned, that closes the case on electron flood theory. Only electrons exist. They make the core, and 1840 electrons is what is the equivalent of a proton, of a neutron. 1839 would be a proton. It wants one more, so it's a positive. It wants to attract a negative. That's what a proton does. But once you get enough of them in the core, and then you get enough of the particles attaching to the blackness, which is the attractor, it says, okay, we've got enough white ones surrounding it, so we don't want any more. We're basically stable at that point. That's what makes a molecule. That's what makes an atom. And the molecules, all they do is they come up and they throw in a guy that wants to get in here, and there's some extra stuff there. He's going to have a black particle attached to him, too. And that one there will hang off a whole nother thing. And then you'll build bigger, bigger, bigger molecules. And then they'll add to each other. And that's how you get matter. All right, I just want you to know, I am not guessing at what I'm talking about. What I just showed you, the actual physical evidence of 50 years of my work. This goes back to heat and how it increases, and decreases in chemical bonds, and how they affect each other, and how the orbitals overlap. And I did all of the things, thermochemistry, and I went through every bit that you can go through to understand the nature of particles and physics and how the attraction works and how heat works and bonding and why molecules form and why heat breaks things apart and why cooling brings things together and all of the different bonding and orbitals. And I did it all, trust me, magnetic propensities and properties and dipole moments. Now this goes back, right now they're talking about the dipole moments creating this issue with the muons. I studied this was 50 years ago, and I knew that it was wrong then. And so what I'm getting at is this is not a guess. I'm guessing at. This goes back so long ago that, and then it goes on and on and on. So you didn't do that. I didn't do this in one day. I did this for my whole life. Now I'm done bragging. Okay, my friends, this is going to be absolutely fabulous, wonderful time for me, reflecting back on the early days of when I was in business and in the electronics business. Everything was wires. Everything ran with wires. And it was all based on copper. And that's why I understand electron flood theory, because of what copper does. When you try to find out something about metals, why is copper different than aluminum? Why is it different than steel? Why is it different than lead? What's the why is that different than this? What's the difference? Well, I know what the difference is. And the only way you can find out is to look for what you would call anomalies. And an anomaly is something that you can't explain. And they cannot explain these interactions with the current thoughts on physics. And that's why electron flood theory solves all of this. And I'm going to show you right now electron flood theory that is very, very hard to dismiss. Now, if anybody out there has a different opinion and can confront my evidence that I am going to show with something to say this isn't right, this isn't right, this isn't right, for whatever reason, any reason, I want to know, because I say electron flood theory absolutely must solve every single energetic reaction, and it does in my mind. And every single thing there is consists of dipole electrons in different configurations. That's all they are. Light is only two electrons together, back to back, as a photon. And then they go up from there into bigger, bigger, bigger until you hit hydrogen, which is the first stable quantity, and that happens to be about 1840 or so electrons, and it shakes until it hits that, because there's a frequency in the universe that just keeps shaking everything like that, and all the electrons buzz back and forth until they hit that resonance frequency. It means they're comfortable at that frequency and they stay together in that ball. But then when you throw a few more of them in there, they say, "Oh, whoa, 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 get out of here, get out of here, shake, get away, get away. We're happy without you." Then when you get enough of them, you have another proton's worth of them. They say, "Okay, now we're pretty happy together. We can keep shaking like this with the universe. We're okay." That's what makes molecules. That's what makes atoms. They grow according to quantities that are comfortable in that shaking vibration. Once you add more heat, they start to shake like crazy. Then they start to disassociate. Then you get all kinds of combustion. You get all kinds of, chemical interactions. That's all they are. Anyway, I hope that made sense. Okay, my wonderful friends, Roger once again, Mud Fossil University, talking about copper and its interaction with magnets. Watch this. I want to show you something. If you have kids or grandkids or people that think they're pretty smart, show them this and let's see what they think, because I think this is amazing and I understand why it's happening. Watch this. This is copper's surprising reaction to strong magnets. And he's going to let that strong magnet, neodymium magnet, swing towards this big chunk of copper. Watch what happens. Boom. Let's go back to see that. Hold on a second. Oh, here it goes. He's coming back. Boom. It just stops. Now, why would it just stop there? It just came, boop. Didn't hit it. We'll probably do it again, I think. Watch, here it goes. Boom. That's just, it looks surreal. It looks like it just shouldn't happen. I do understand what's happening and why magnets and copper interact in such a strange way. And copper is right up in here in the transition metals. And it has a certain affinity to hold on to electrons in copious quantities. And because of that, it creates a huge rubbery field around itself, and that thing is banging into that rubbery field and just interacting, and not even it can't get in hard enough to hit. And that's a pretty hard chunk of metal, and it comes down and just settles right there, boom, because it's like hitting into a pillow. Okay, like I say, I understand copper extremely well, and I understand what's going to happen here. And he's going to let that magnet go, and you're going to see what happens.
The magnet loses all of its momentum at the very last moment in a way that almost looks supernatural. It reminds me of a scene in the second Matrix movie where Neo stops bullets in midair. What's really happening is, of course, the same thing that has happened in my other examples. The magnet's momentum is slowed by a...
All right, I'm going to have to go through this thing very carefully to show you what really is happening. It's an entanglement of push-to-shove forces that are so excessive they can't touch each other, but it's just like a pillow hitting it. And you'll see it doesn't quite hit here, and it really doesn't do much of anything, and it just barely settles back. So we know it's sort of just losing some of its momentum. Watch carefully.
It reminds me of a scene in the second Matrix movie where Neo stops bullets in midair.
This is where it's going to happen, really right here. Watch.
Is, of course, the same.
Boom. Now watch. It didn't quite hit here, and it'll just barely walk itself back out.
Same thing that has happened in my other examples.
That wasn't slow motion. That was just normal. So it hits, and it's in this pillow cloud of electrons, and it just sort of works its way back out slowly, because it's still trying to be sucked in and pushed out at the same time. Very interesting interaction. We're going to be going through all the different transaction metals and magnets and the earth and the spinning and how it's rubbing in a vacuum of space, which is not a vacuum. It's all particles, which I showed those particles. Light is a particle. It's coming from somewhere. So when it's coming from the sun, it's obviously particles. There is no vacuum of space. We are scrubbing our earth through those particles. I've shown this a bazillion times. They don't understand global warming. Until you understand electron flood theory, the case is closed on everything. All right, somebody contact me and I will explain exactly. Well, it's so simple that a 10-year-old can explain it, can understand it. It's push to shove. We're scrubbing. And that is crushing our Earth, basically. The more particles we put in our atmosphere, blowing up our balloon, the harder it's crushing down against them. That means earthquakes, storms, swirling, and all that. And if they're spraying particles in the air to stop and think the sunlight is going to bounce back out, they're insane. Those particles are going to scrub much harder than gases. If they have literal particles that are up in the air, they're not supposed to be there, and they're scrubbing, they will increase the interaction between our layer of the atmosphere and the layer we're scrubbing through, which is why our weather systems happen. They happen, it's just so obvious when you take a look at it. If they put those particles up there, we're going to react, could be thousands of times harder. It could literally destroy the atmosphere. And we'd have to wait for those things to come out of there somehow. I hope they didn't figure a way to make them lay up there forever. And I'm sure they're trying. We're walking down the wrong roads. All right, I love you all. Goodbye. Now, this is just literally unbelievable. My friend from NASA, he was, well, anyways, he was with the European Space Agency, NASA, and all that stuff. He sends me literally zillions of things. Pedro, thank you, buddy. You are an inspiration. And they're good, and usually they're pretty quick. This one's very long, but it is absolutely unbelievable. And it's just exactly what I'm studying. He's talking about copper and the sunlight to everything. And that's all just what I just told you. There is nothing other than electrons. And electrons make photons. Photons are sunlight and particles and all that coming out of the sun. Sunlight to everything, catalyzing sustainable future. Just came out. If there's anything, I mean, it's unbelievable. So I commented on here. And let's see if anybody ever... There's only 5 comments, and it came out May 4th. That's I don't know, a couple days ago, and this is Caltech, and I'd love to interact with some of these people, because I'm going to tell you right now, I understand what's going on with copper. I was so deep into copper. I don't know. I think I showed. Well, maybe I didn't show you this. This is what I did for a living. My whole life, work with copper. I understand it. I understand signals. I understand grounds. I understand electromotive force, electrons, motive forcing. I understand reverse electromotive force, causes static discharges, causes all kinds of issues. Originally, long ago, in all kinds of equipment, we had to deal with it, with capacitors and filters and diodes and all kinds of things. So I'm not coming at this blind. And I'm going to have a very, very long series about molecular interactions, specifically focusing around copper. Because there's something a little strange with copper. Copper has so many extra electrons. As I showed you with that magnet coming down, poof, there's just a cloud of electrons around copper. I got to figure out what that nuclear configuration is that could account for such an excess of particles that are pushers and shovers. Something's not right there, because it also just hugged up to there for a second. There's some stability and some pushed and shoved, and there's all kinds of problems right in there. Anyway, it's going to be fun for me. It'll probably be boring for about everybody else, but I'm going to have a good time. All right, once again, I love you all, and Pedro, thanks, buddy. Just keep them coming, my friend.